If you look at this last set of problems that are on the assignment for Chapter 7, the problems on 85 through 90 are all about identifying and using some of the basic properties of elements on the periodic table. And these properties are trends that you should understand. And so we're looking here at number 85 that says something about arrange these in increasing size. Well, what is the periodic trend for size? There are two periodic trends that you need to be familiar with when it comes to the size of atoms. Now notice these are all atoms, none of these are ions, and so that makes it a little bit different, or a little bit simpler probably. As you go down any group, you will notice that this gets larger. Now you should also understand why the radius gets larger as you go down a group. The radius gets larger because you're adding electrons to outer shells. The valence electrons have a higher principal quantum number. So anytime you compare, say, tellurium and sulfur, this periodic table is difficult to find tellurium and sulfur. I think we can use this periodic table. Here we go. Here's tellurium, selenium, and sulfur. And so we're looking at these three elements. So you should be able to place those in order of increasing size, because sulfur is at the top, and then selenium, and then tellurium. So that would be sulfur, selenium, tellurium, if you're placing those in order. Potassium, bromine, and nickel. Now these are not going to be right next to each other. So we're looking here at lithium, sodium. Here's potassium. Bromine is going to be clear over here. And nickel is going to be right, I can almost see it with my bifocals, right there. And so what you will notice in periods as you go across, there is a trend to get smaller. Now there's a little right here between the, see, I'm drawing my line in the 6th period, and so between 5F and 6P, there's a little bit of an anomaly there where the size jumps up because we're adding electrons to the outer shell once we get to 6P here. But then as we add more and more neutrons to the nucleus, more and more neutrons to the nucleus, but the electrons are not going into an outer valence shell, we tend to get smaller again. So the reason that these get smaller is as you go across a period, you're getting additional nuclear charge, but you're not getting any additional shielding from inner electrons. And so as you look at these, you'll see the trend between potassium and nickel and bromine. And if you're supposed to place these in order of increasing size, it appears that bromine would be the smallest, nickel would be a little larger, and potassium would be the largest. So barium, silicon, and fluorine, we'd be looking here for, get a few things erased, barium, silicon, and fluorine. Now barium is right here on your periodic table. Silicon is over kind of with the metalloids right up here. And fluorine is right up here. So you'll notice we're kind of looking at a series of elements that are in very different periods. And so as you go to larger and larger periods, you're going to get larger and larger shells. So fluorine is going to be the smallest because it's in the 2nd period. Silicon, of course, it's the trend is to see the largest down here and the smallest up here, like this. So fluorine is smallest, silicon is next, and cesium is the large. Oh, cesium was that? I'm sorry, silicon. Barium. Where was barium? Barium is the largest. Somewhere I had circled cesium, and that wasn't in the question. So you see the same kind of questioning here on number 86. So looking at rubidium, sodium, and beryllium, as long as I've typed those in correctly. So here's rubidium, sodium, and beryllium. It's probably easy to see that beryllium is smallest because it's in the lowest period. So that would be beryllium, sodium, and rubidium. Did I get that right? Is that the rubidium there? No. I can't even read it. That's rubidium, yeah. Okay, so strontium, selenium, and neon. Strontium is right here. Selenium is over on the other side of our periodic table, atomic number 34, right here. And neon is up here, atomic number 10. Now the difference here between neon and selenium is not quite so obvious. So here we're working on 86B. Neon, selenium, strontium is the order. Neon, selenium, strontium. And you will see that that also progresses from the lowest energy level to the highest. So see if you can finish that out with iron, phosphorus, and oxygen. Moving on to 87. 87 is about increase in ionization energy. And remember, ionization energy is the energy required to remove an electron from an atom. The more electrons you remove, the greater successive ionization energies will be. And in fact, if you go across a period, say from lithium to beryllium, excuse me, let me back up and do it this way. Say you're going to take electrons away from aluminum. The first electron, of course, will take more energy. The second one will take more. The third one would take more because we're removing successive electrons from the third energy level. To remove the fourth energy level electron, back up here, excuse me, to remove second energy electrons from aluminum, wish I could start this over easier. To remove second energy level electrons from aluminum, you would be having to remove 4 electrons, and the energy level change from the outer valence shell to the core electrons represents a huge jump in ionization energy. But these are all just atoms that we're removing electrons from. And the trend is this, down at this corner is the lowest ionization energy. So these atoms tend to lose electrons easily. And in fact, we know that cesium, it's very easy to strip electrons off cesium and cause it to turn into a positive ion. Compared to that, it's much more difficult to remove electrons from things like fluorine and helium. So looking here at tellurium, sulfur, and selenium. Let's see if we can find those here on the periodic table. Tellurium is over here, atomic number 52. Sulfur is here. Selenium is here. Now the trend is that as we get further from the nucleus, it's easier to remove those electrons. There's more shielding effect from the core electrons. So as we go down here, the ionization energy tends to get lower and lower. So we would be looking at tellurium, selenium, and sulfur. Tellurium, selenium, and sulfur. if we're supposed to put them in order of increasing ionization energy. So potassium, bromine, and nickel. Here we have potassium, here we have bromine, and here we have nickel. So those are the same as we looked at in the trend for atomic radius. Now here, remember, this we go across a group, across the period, we tend higher and higher ionization energies because we are in the same valence shell, but we're adding more and more positives greater there. So potassium is going to be followed by and energy in that. Silicon and fluorine. Those, if we can find them all. Barium, silicon right here, and fluorine. And you can see that follows right along that line, with the lowest being barium, next silicon, and next fluorine. So those are already in the correct order. Moving on to 88, we see a similar kind of problem. You should be able to work yourself through 88. And 89, which atom has the smallest radius? I think we're going to go to this on another video.